Welcome in the sixth section that will be the last one in this course. In this section we're looking at the tips and tricks, and also we'll be looking what simple things can be done to make our algorithms working better. So firstly we'll see how to tune layer responsible for extracting features. We will do a recap of parameters that are affecting the result of our deep learning model generations. Next we'll see how the number of iterations is affecting precision. We'll see that as more iterations will be introduced in our model, the precision will be better, but also there is a threshold after which there is no need to add more iterations. So we will try to find that threshold in the next video. Also, we'll be looking at the tips on how many features should layer produce. So this is also important to understand expected result. If we want to predict some number that gives us an answer, we should have only one output features. But sometimes we want to have more output features that could be used, for example, to train another model. So we'll be looking at this aspect. Finally, we'll see two most common mistakes when using deep learning algorithms in production. So we will see what should be changed when you are using that in production. And this is a first video on which we'll be looking how to tune your layer responsible for extracting features. So in this video, we'll be looking at the important parameters. We'll be looking at the number of input features, expected output features, and hidden features. So we'll go through the examples that were done in this course, and we will be focusing on the part of tuning number of layers and classes. So in the first section, when we were doing predicting comments using RNN, we created multi-layer network that had only two layers. First layer has number of input equal to size of the vector, and output was equal to 2. And this is very important. If we focus on the output, you remember that we wanted to classify our data into two classes, positive and negative. So even though our input was really huge, so we have 300 elements as a feature vector, we wanted to reduce it to only 2. So this is very often useful in deep learning algorithms, to have features that are really hundreds of them in the vector, but reduce them to the number of outputs that is really finite, like 1, 2, 10 or something like this. So deep learning is very good for that, and the more features you have as an input, the better, because the results will be more accurate, because deep learning network will be able to pick the proper features and give them proper weights. In the second video, we created the MNIST anomaly detector. So input was equal to 784 because our images had 28 pixels width and 28 pixels height. So also a lot of features. Then we reduced it to the 10 because we had 10 digits, but as you remember, we wanted to reproduce it, so redraw it. So we were get back to the number of output that was equal to 784. So we can see that number of input was equal to number of output. So also this is useful and often used practice if you want to recreate something based on the input features. So if we were using input features of the image, so every pixel is a feature, we can produce also similar output to recreate that picture. In the fourth section, we created more layers because we wanted to achieve better predictability and probabilities of result. But let's look at the number of outputs. Number of output in this example was equal to 10, and it was very important number because we wanted to classify numbers into classes. So if you will look at the numbers in English alphabet, for example, you can see that there is from 0 to 9. So there is 10 numbers. So if you want to extract information from already predefined dataset with some boundaries, you need to get those boundaries and use them as the output number of classes. So for example, if you want to find out and classify things into, for example, letter in alphabet, then number of output classes should be equal to number of alphabets. Finally, we were looking at the logistic regression that sum two numbers, and this case is obvious. We wanted to have only one output because that was used to mimic our sum. So in this example, we reduce from 2 to 1.